All right, the heights and the shoe sizes for a group of students are measured and recorded up here on a scatter plot. You can see all the data points of all the measurements, and on the vertical scale we have shoe size, on the horizontal scale we have the heights of these students and their shoe sizes respectively. Now you can see the way the pattern and the strength of the dispersed data points there, which seems to show a moderate to strong correlation. There seems to be a strong correlation. Now remember, correlation is the measure of the strength of a linear relationship. And being linear, we can represent that and approximate that linearity by putting a line of best fit, and it's already been put there for us. So that line approximates and represents those data points. Now if you count them, it'll tell you how many students. I think I counted them before. There are 17 students, but that's not the outcome. The outcome for us is to work out the equation of this line of fit. Why do we need it? Because it helps us make predictions and estimates if we have one variable and we can find the other variable just reading off that scale. So let's get stuck into it. We're going to be using these formulas here. First of all, many of you are familiar with this gradient formula. It gives us the slope, y2 minus y1, x2 minus x1. For this example, we'll say y is there and x is horizontal, that's the height. And the equation of the line y equals mx plus b, b being the y-intercept where it cuts right over there. So let's go through the 3 steps. Number 1, let's get the gradient. Number 2, let's get the y-intercept. And number 3, let us find the equation, sub those points into the equation. So let's go ahead and do that. So step number 1, we're going to use the gradient formula right here so we can work out the gradient or slope for this line. Now if we look at this, you can actually find some points. You could find any point that goes on here and across there. You can find 2 points. I like to look for whole numbers. There happens to be 2 points already on the scatter plot. And the first one would be 170 going across to between 9 and 8, 8.5 there. So 170, 8.5. So let's write down those coordinates. $170 and 8.5. Okay, that's our first coordinate right there. And the next coordinate I'm going to try for this one here, that's 180. And 180 goes up to and across to 12. So that's a pretty big shoe size and a pretty tall person. So you can see here that the taller the person, the bigger the shoe size, and that kind of makes sense because we have a positive correlation. As one variable, the height increases, so does the other variable, the shoe size increase also. So that's a positive correlation. So there are 2 coordinates. Let's mark them up so we can get substitute them into the gradient formula. So x1, y1, and x2, y2 right there. Let's put it straight into the formula. So m, the gradient, equals y2, 12 minus y1, 8.5, all over x2 minus x1, 180 minus 170. Let's work that out. Gradient m equals 12 minus 8.5. That's going to give us 3.5. So I'll call it 3.5 as a decimal, all over, whoops, that's 180 here. 180 minus 170, that's only going to be 10. That's only 10, so let's put that here. So our gradient is 3.5 over 10. Dividing by 10, the 3.5, we're left with a gradient of m equals 0.35 as a decimal. So that's our gradient, our slope. It's positive, so you can see it's going up in the positive direction. So we got that. Step number 2 is to get the y-intercept. Now, what you would normally do is look at the line of best fit here, and you go across to the y. Let's assume that's the y there. It's going across here, so we got 7 right there as the y-intercept, and no, you can't use that. Why can't you use that 7? You can't use it because down here, if you look at the scale, we're going 180, 176, 172, 168. That's not 0. It looks like 0 height would be across all the way down here somewhere. So cutting through 7 is like, that's like about 166 over here. That's not 0. We need the y-intercept where this height comes down to a 0. So that's the y-intercept. So we can't use 7. what do we use? Well, we need to substitute two of these points, any one of these points, pick a point, into this formula here to find the unknown y-intercept b. Okay, that's what you do. You use the formula. So let's go ahead and do that. So let me just put a little boundary there. So let's use y equals mx plus b. We're after b, that's the unknown. Let's substitute one of the points. So one of the points I'd like to use would be this one here. So let's pick this one. You can pick any one. We're going to pick that one right there. 180 for x and 12 for y. So let's put them in there. I'm going to drag and drop the 12 for the y there. So 12 equals m. We know what m is. It's 0.35. There we go, 0.35. And that's going to be an x value of what? X will be 180 times 180, right? Plus b. Plus b. That's the unknown. We don't know what that is. Okay, so let's keep working this out. Let's multiply these two guys here in the 12. So that means 12 equals 0.35 times 180. On the calculator, that's going to give you a value of about 63, I think. Yep, 63 plus b. There's our b there. Let me just put it in. Plus b. Okay, so 12 equals 0.35 times 180. That makes 63. Drag and drop the b down there. That's the unknown. That's what we're looking for. 12 equals 63 plus b. Let's subtract 63 from both sides. Let's do that. Take away 63 so we can make b home alone. Minus 63 from that side. So that's going to be 0. So we're left with just b on this side equals 12 take away 63. That's going to give us a negative value. That's going to be negative 51. So b equals negative 51. That's a little different to 7, isn't it? It's pretty different, isn't it? So let me just box that up there. All right, that's our y-intercept b. It's negative 51. Now that we have b and we have the gradient, all we have to do is take these two guys, drag and drop them into the equation, and that will give us the equation for the line of best fit, that red line over there, which best represents that scatter plot, all those data points. So let's drag and drop them in. So there's our two values. So y equals m, which is 0.35, x minus 51. That's our equation. Now that's in terms of y and x. We want to put it in terms of, let's call this here h for height, and over here s for shoe size. So let's replace the vertical y with an s and the horizontal x with an h, so the formula is appropriate. So let's do that now. So let's replace them. So y is s, so that means we're going to have s equals 0.35x, sorry, not x. So what's the horizontal? It's h minus 51. So that's our equation. So S shoe size equals 0.35 gradient h, horizontal variable, h minus 51. And that's the equation for the line of best fit. There you go. Hope that helps.